Welcome to sureshbhattclasses. We are solving question on quantitative aptitude topic numbers. All the topics of quantitative aptitude are useful for all competitive exams like RRB, Bank PO, SSC CGL, Railways and many government job exams and job interviews. These topics are also useful for many entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are solving question on numbers based on factorial. Our question is, find highest power of 100 in 125 factorial. The given options are option A 15, option B 31, option C 34, option D 17. Before solving this question, I request you to please subscribe to this channel. We factorize 100 into prime factors. 100 equal to 2 to the power 2 multiplied by 5 to the power 2. Now we will find the maximum power of 5 in 125 factorial, as power of 2 will always be more than power of 5 in 125 factorial, and we will need only to find the power of 5 to solve our question. Now we will successively divide 125 by 5. 5 times 25 is 125. We again divide 25 by 5 and 5 times 5 is 25. Now we again divide 5 by 5 and quotient is 1. Now we will add all these quotients. 5 plus 5 is 30 plus 1 is 31. So this is equal to the maximum power of 5 is 31. This will give 5 to the power 2 to the power 15, as we wanted to have the maximum power of 5 to the power 2, and 5 to the power 2 will be 15. So the maximum power of 100 will be 15 in 125 factorial. And from the given options, our answer is option A 15. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, the highest power of 10 in n factorial is 22. What will be the highest power of 10 in n plus 1 factorial? The given options are option A 23, option B 25, option C 24, option D 27. Before solving this question, I request you to please subscribe to this channel, as 10 is not a prime number and 10 can be factorized into prime number, and the prime numbers are 2 multiplied by 5. So whatever may be the power of 5 in any factorial will be the same power of 10 in that factorial, because 2 being smaller than 5, 2 will have more power than 5 in any factorial. So for making 10, we will have sufficient power of 2, and whatever may be the power of 5, that will be the power of 10 in that factorial. It is given that the power of 10 in n factorial is 22. We successively divide 95 by 5 to prove that the maximum power of 22 is in 95 factorial. 5 divides 95 for 19 times, and 5 again divides 19 for 3 times, and 19 plus 3 is 22. So 95 factorial has maximum power of 5, which is 22, but this will be same. 22 power will be in 96 factorial. It will also be in 97 factorial, It will be in 98 factorial. It will also be in 99 factorial. As 5 divides 95 to 99 for 19 times, and again 5 divides 19 for 3 times, and the sum will be 22. So whatever may be the value of n factorial from 95 factorial to 98 factorial, the power of 5 will be 22 in n plus 1 factorial as well. If it is n equal to 95, then n plus 1 will be 96. If n equal to 96, then n plus 1 will be 97. And if n is 97, then n plus 1 will be 98. And if n is 98, then n plus 1 will be 99. And in n factorial, which is 95 factorial to 99 factorial, the maximum power of 5 will be 22. But it changes in 100 factorial. So what we should do? We should take the maximum value of n equal to 99. Then n factorial will be equal to 99 factorial. Then n plus 1 factorial will be 100 factorial. Now we will find the maximum power of 5 in 100 factorial. So we successively divide 100 by 5. So 5 times 20 is 100. We again divide 20 by 5, and 5 times 4 is 24. And now 4 is not further divisible by 5. So we add these two quotients. 20 plus 4 is 24. So the maximum power of 5 will be 24 in 100 factorial or n plus 1 factorial. And that will be the power of 10 in n plus 1 factorial. And from the given options, our answer is option C, 24. That will be the maximum or highest power of 10 in n plus 1 factorial. I hope you have understood the concept as well as solution of this question. We go to the next question. Our question is, find number of zeros at the end of 50 factorial. The given options are option A 5, option B 9, option C 10, option D 12. Before solving this question, I request you to please subscribe to this channel. We have to find the number of zeros at the end of 50 factorial. And this is nothing else but finding the maximum power of 10 in 50 factorial. But 10 is not a prime number. So what we do, as we know that 10 equal to 2 multiplied by 5, and power of 2 will be more than power of 5 in 50 factorial. But for making 10, we need equal powers of 2 and 5. So whatever may be the power of 5, that number of powers we will take from power of 2 and we will make it the power of 10. Therefore, we will only find the power of 5 in 50 factorial, and we can find it by successively dividing 50 by 5. 5 divides 50 for 10 times. Again 5 divides 10 for 2 times. So the number of power of 5 is 10 plus 2, which is 12. So that will be the power of 10, and 10 to the power 12 in 50 factorial. So number of zeros equal to 12 in 50 factorial. And from the given options, our answer will be option D, 12. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of 2 multiplied by 4 multiplied by 6 multiplied by 8 multiplied by up to 200. The given options are option A 24, option B 25, option C 20, option D 23. Before solving this question, I request you to please subscribe to this channel. 2 multiplied by 4 multiplied by 6 multiplied by 8, and this goes up to multiplied by 200. We take 2 from every number. So these are total 100 numbers. Then this will be 2 to the power 100 multiplied by 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by up to 100. This is nothing else but 2 to the power 100 multiplied by 100 factorial. Now we have to find the number of zeros at the end of this number, 2 to the power 100 multiplied by 100 factorial. And the number of zeros is nothing else but it is the maximum power of 10 in this given number. But 10 is not a prime number, and 10 is equal to 2 multiplied by 5. And we will find the maximum power of 5 in 100 factorial, and that many number of power we will take from the power of 2. That will make the power of 10. So we will find the maximum power of 5 in 100 factorial. So we successively divide 100 factorial by 5, and 5 divides 100 for 20 times, and 5 again divides 20 for 4 times. So 20 plus 4 is 24 is the maximum power of 5 in 100 factorial, and that will be the power of 10 in the given number, 2 multiplied by 4 multiplied by 6 up to 200, or 2 to the power 100 multiplied by 100 factorial. So number of zeros at the end of the given number equal to 24. And from the given options, our answer is option A 24. We go to the next question. Our question is, find number of zeros at the end of 1 multiplied by 2 multiplied by 3 multiplied by up to 60. The given options are option A 5, option B 7, option C 10, option D 14. Before solving this question, I request you to please subscribe to this channel. 1 multiplied by 2 multiplied by 3 multiplied by 4 and multiplied by up to 60 is nothing else but it is 60 factorial. And we have to find number of zeros at the end of 60 factorial. This is nothing else but the power of 10 in 60 factorial, and 10 is not a prime number, so 10 equal to 2 multiplied by 5. We know that the power of 2 will be more than power of 5 in 60 factorial, but we need equal powers of 2 and 5 to make it 10. So we will find the maximum power of 5 in 60 factorial, and that will be the power of 10 in 60 factorial. So we successively divide 60 by 5. 5 divides 60 for 12 times. We again divide 12 by 5, and it divides it for 2 times, as 5 times 2 is 10. The sum of 12 plus 2 is 14, and that is the maximum power of 5 in 60 factorial, and that will also be the power of 10 in 60 factorial. So number of zeros in 60 factorial equal to 14, and from the given options our answer is option D 14. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of 5 multiplied by 10 multiplied by 15 multiplied by up to 100. The given options are option A 18, option B 20, option C 21, option D 15. Before solving this question, I request you to please subscribe to this channel. 5 multiplied by 10 multiplied by 15 multiplied by up to 100, and we can take common 5 from each number. The total number are 100 divided by 5, which is 20. So if we take common 5, so it will be 5 to the power 20 multiplied by 1 multiplied by 2 multiplied by 3 multiplied by 4. This will be up to multiplied by 20. So this is equal to 5 to the power 20 multiplied by 20 factorial. Now we have to find the number of zeros at the end of this number. This is nothing else but the power of 10 in 20 factorial. But 10 is not a prime number, so we can factorize 10 into 2 multiplied by 5, and whatever may be the power of 5 and 2 together, that will make the power of 10, and that will be the number of zeros at the end of the given question. But we already have 5 to the power 20, so we have to find the power of 2 in 20 factorial, and the equivalent or equal number of power we will take from the power of 5 to make it power of 10. So we find the number of 2's in 20 factorial or power of 2 in 20 factorial. So we successively divide 20 by 2. 2 divides 20 for 10 times. We again divide 10 by 2. It divides 10 for 5 times. We again divide 5 by 2. It divides it for 2 times. We further divide 2 by 2 and it divides for 1 time. Now we will add all these successive quotients. 10 plus 5 is 15, plus 2 is 17, plus 1 is 18. So the maximum power of 2 is 18. We have more power than 18 in 5 to the power 20. So we can take 2 to the power 18 and 5 to the power 18 from 5 to the power 20 already we have. So this will make 10 to the power 18. This will give number of zeros at the end equal to 18. There will be 18 zeros at the end of the given question. And from the given options, our answer is option A, 18. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the number of zeros at the end of 10 multiplied by 20 multiplied by 30 multiplied by, we go up to 400. And the given options are option A 50, option B 48, option C 49, option D 51. Before solving this question, I request you to please subscribe to this channel. We have to find number of zeros at the end of the given number. 10 multiplied by 20 multiplied by 30 multiplied by, it goes up to 400. We can take common 10 from each number, and 400 divided by 10 is 40. So there will be 40 tens we can take out from the given number. So we can write it as 10 to the power 40 multiplied by 1 multiplied by 2 multiplied by 3, and it goes up to multiplied by 40. This is equal to 10 to the power 40 multiplied by 40 factorial. Now we have to find the power of 10 in 40 factorial. As 10 is not a prime number, and prime number in 10 are 2 multiplied by 5. We know that power of 2 will be more than power of 5 in 40 factorial. So we will find the power of 5, and that power will be power of 10 in 40 factorial. So we find the power of 5 in 40 factorial. We successively divide 40 by 5. 5 times 8 is 40. We again divide 8 by 5. and 5 times 1 is 5. So this is 8 plus 1 is 9. So there will be maximum power of 5 in 40 factorial, that is 9. So it will be power of 10 in 40 factorial. We already have 10 to the power 40 in given number multiplied by 10 to the power 9 from 40 factorial. So total number of power is 10 to the power 49. 40 plus 9 is 49. And therefore the number of zeros in the given question will be 49. And from the given options, our answer is option C, 49. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of 1 multiplied by 3 multiplied by 5 multiplied by, continue up to multiplied by 99, and to this multiplied by 256. The given options are option A 8, option B 10, option C 12, option D 15. Before solving this question, I request you to please subscribe to this channel. We have to find the number of zeros in the given question, and on observing the question has all alternate number in multiplication from 1 to 99, and in multiplication of that we have 256. 256 is nothing else but 2 to the power 8. Now we have to find the number of 5s in 1 multiplied by 3 multiplied by 5 up to 99. So number of 5s are 5, then it will be 15, then it will be 25, then it will be 35, 45, 55, 65, 75, 85 and 95. And in 25 we have got the 2 5s, 5 to the power 2. Also in 75 it is 25 multiplied by 3. So again we have the 25 in it, which is the 5 to the power 2. So we can find the power of 5 in these all 5s. So from 5 to 95 we have number of 5s 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have got 2 5s in 25 and in 75. So 10 plus 2 is 12. So number of 5s in all these 5s are 5 to the power 12. And in 256 we have 2 to the power 8. So total number of 10s we are going to get is 10 to the power 8. We will take 5 to the power 8 from 5 to the power 12 multiplied by 2 to the power 8, and that will give us 10 to the power 8. So the number of zeros in given question is 8. And from the given options, our answer is option A, 8. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of product of 1 multiplied by 2 multiplied by 3 multiplied by up to 500. The given options are option A 50, option B 124, option C 150, option D 135. Before solving this question, I request you to please subscribe to this channel. The product of 1, 2 and up to 500 is nothing else but 500 factorial. And we have to find the power of 10 in 500 factorial. 10 is not a prime number, so we will take the factor of 10, which are 2 and 5, and we will find the power of 5 in 500 factorial, as power of 2 will be more than power of 5 in 500 factorial, and we have to have the equal number of powers of 2 and 5 So if we find the number of 5s or power of 5 in 500 factorial, that will be the same as the power of 10 in 500 factorial. So we successively divide 500 by 5. 5 divides 500 for 100 times. We again divide 100 by 5. It divides 100 for 20 times. We again divide 20 by 5 and we get 4. 5 divides 20 for 4 times. Now we add all these successive quotients, which are 100 plus 20 plus 4 is 124. So power of 5 in 500 factorial is 124, and this will be also the power of 10 in 500 factorial. Therefore, the number of zeros are 124, and from the given options, our answer is option B, 124. I hope you have understood the method of solving such type of questions. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.